In our last video, we ended with a couple of questions that I would like to now answer. Our first question was, just like we made lists called Molt2 and Molt3, can we use our list comprehension techniques to create lists called Molt5 and Molt7 that do something very similar to these two lists? Create lists of the multiples of 5, going from, in this example, 10 up to 100, and in this example, 14 up to the largest multiple of 7 that's less than 100. Can we create those two lists with our list comprehension notation? And the notation that I've chosen for my Molt5 and my Molt7 is very similar to the notation for Molt3. I made a slight change, and instead of doing regular floating point division and then casting this value as an integer, I just chose to do something a little more straightforward for Molt5 and Molt7 this time around, and to just use integer division on these two quantities before adding my 1. If you chose to do these computations, since they're not too complicated by hand, the values you should have right here are 21 and 15. So hopefully this was a really approachable exercise given the previous video. The second video is more of a review of things that we've done in the past. How would I combine these lists into one large list called not primes? For me, I would just use regular old addition. I'd create a list called not primes, and the value that I would like to assign to it is the concatenation of these lists. First Molt2, then Molt3, then Molt5, then Molt7. Now you might have chosen something a little bit fancier here. Again, that's totally okay. My not primes list is going to have repeats in it. For example, 6, which is both a multiple of 2 and a multiple of 3, is going to appear twice in my not primes list. But for me, I'm not particularly concerned with that, so I just put them all together in the most straightforward way I could. Now, the much more challenging question that we saw at the end of the previous videos was, how would we then take a look at all values between 2 and 100 and go through and keep track of something if it's not in this list? One thing that you could do is go back to the drawing board and say, hey, it's code that will work, right? Why don't I create a list called primes? In the beginning, it's an empty list. Then I will loop through the numbers, starting with 2 and ending with 1 less than 101, and then I can use a branching statement. Be prepared for the double negative. If it's the case that this value x is not in the list of not primes, then that means that it's a prime number, and I'd like to take my list of primes and add to it this value x. Notice that there's no else statement here. If x does happen to be in the list of not primes, then I don't want to do anything to it. I just want to let it pass and move on to the next value in my range. And see that when I print the primes here, I get something over here, which to me as a mathematician is very familiar as a list of primes. If you're uncertain if that truly is the list of primes, we could hop on over to some mathematical software to verify it for us. What I'm working in right now is mathematical software called Mathematica, whose sole purpose is to handle complicated mathematical tasks. And you can just ask Mathematica directly for prime numbers, list me the first 25 of them, and Mathematica spits out this list of values, which is precisely equal to the values we have right here. So these are our answers to the previous questions. Other than checking your understanding for the first two problems, what I'm really trying to hint with at item 3 is there a way to not have to do all this code and to somehow combine branching statements with list comprehension? And what's truly wonderful, of course, is that there is. Not only can list comprehension be used to combine the creation of lists with looping, we can use an alternative form of list comprehension to combine the creation of lists, loops, and branches, which is hugely powerful for condensing code and making it significantly more readable. So notice what I've added to the usual syntax for list comprehension. We studied in the previous videos the first 3 parts, expression, member, and iterable, for list comprehension. But what I can do is add the Python reserved word if and a conditional statement to check. And if I use this form of list comprehension, I will create a list whose name is list name, and the values that will be added to that list are all of those that have this expression taking on the different values in this iterable, but only if this conditional statement is true of that expression value. Just to give an example, the code that we have over here on the left that we just walked through for creating this list of primes can be condensed into a single line of code, which says, I would like as my expression to look at all things x that are in the range of values between 2 and 101, but I only want to add them to my list of primes if that value is not in my list of not primes. So this if statement that I would have had inside the for loop or after it in terms of top-down coding, it now comes after the for part in my list comprehension in this left-to-right coding. That exact if statement is this exact if statement here, and this one line of code will produce the same output as all of these lines of code over here. So this is one way we can go about combining the creation of lists, loops, and branches in order to make really concise list comprehensions.